Hi everyone. Today we will learn about regression analysis in biostatistics, modeling relationship in health data. Our learning objectives are understand the purpose of regression analysis in health research, learn about simple linear regression, apply regression to a health related data set, examine and interpret model output, understand and check the regression assumptions. What is a regression analysis? A statistical method for modeling the relationship between a dependent outcome variable y, one or more independent predictor variables x, predicts the expected values of y based on the x used for estimation, predictions, and causal inference. Simple vs multiple linear regression. Simple linear regression, one outcome variable and one predictor. Multiple regression, one outcome variable and two or more predictors. Today's we will focus simple linear regression. Regression analysis, measure of relationship between two or more variables and measure of amount of effect of independent variables on dependent variables. The fundamental concept regression analysis deals with finding the best relationship and the use of method that allows for the prediction of the response variable on given values of the regressor independent variables. There are some assumption of regression analysis. The first one is linear or linearity between the two variables, and the second one is the independence of errors term, and the third one is homoscedasticity, means constant variance of errors, normality of residuals, the fourth one, and no multicollinearity, only relevant in multiple regression. Here we use method of least square and find the best fit for the regression analysis. Consider an example. Assume that we want to look at the relationship between two variables, height and self-esteem of medical students. Perhaps we have a hypothesis that how tall you are affects your self-esteem. We collect some information on 20 male students' height. Height is measured in inches and self-esteem is measured based on the 1 to 5 rating 4 items scale. Here hypothesis beta 2 is equal to 0. There is no change in self-esteem of students after the increase of 1 unit in their height. And alternative hypothesis is beta 2 is equal to 0. There is a change in self-esteem of the students after increase 1 unit in their height. This is the two-tail hypothesis test. The regression equation formula y is equal to beta naught plus beta 1 x plus e. Here y dependent variables, self-esteem, x independent variable, height, beta naught is intercept and beta 1 is slope. Change in self-esteem per unit increase height, and E is error term. Interpretation of regression coefficient y is equal to beta 1 plus beta 2 x. Beta 2 with sign of plus, beta 2 with 1 unit increase in independent variable x, the dependent variable y is increased up to beta 2 unit. Y is equal to beta 1 minus beta 2 x, beta 2 with minus sign with 1 unit increase in independent variable x, The dependent variables y is decreases up to beta 2 unit. R square coefficient of determination. This quantity is a measure of the proportion of variability explained by the fitted model in the dependent variables. For this example, first we open our SPSS program and then create the variables in variable view. First variable is serial number and the second variable is height and third variable is self esteem of a person of a students. In data view, we enter the all observation 1 to 20 in serial number variables and heights and self esteem in height variable and self esteem variable. Evaluation of relationship or first assumption of linearity. For this purpose, we plot scatter plot, go to graphs, legacy dialogues, and then go to scatter slash dot. The scatter plot window is open. First, we select the simple scatter and press the button define and move our height variable in x axis and self esteem in y axis and press button OK. In output viewer, we got the graph or scatter plot. We double click the scatter plot and add fit line at total button. We press the button add fit line at total. This line show the linearity or linear relationship between the both variable. Linear regression analysis. For linear regression analysis in our SPSS, we go to analyze regression and select linear. Linear regression window is open and we enter the height variable in independence and self esteem variable in dependent and press the button statistics and check the model fit and estimates and press continue and OK. We also check the confidence interval 95% level and press button continue. Then press the button save. Linear regression save option is open and check the button residual standardized residual and check the button predicted values standardized predicted values and press continue and OK. The output we will show the regression analysis. The first table show the variables enter and removed and the second table show the model summary and third table ANOVA and fourth table show the coefficients regression coefficients. In first and second table model summary are show the correlation coefficient 0.731, and R square show the coefficient of determination 0.534, and third table show the ANOVA F, which means model is significant, and the fourth table show the coefficient. Here we have two types of beta coefficient: unstandardized coefficient or standardized coefficient. We check the unstandardized coefficient. Constant value beta naught is equal to minus 0.866, and beta 1 has height of a person beta 1 is equal to 0.071. Here significance value is 0.001, which means the significantly increase in self esteem 1 unit when we increase in height, and the confidence interval also show the significance. The second assumption is independence of error. Observation must be independent. See the design. Example, use individual patients. Example, use individual students. Assumed independent. The third assumption is homoscedasticity, constant variance of residual across all levels of X. Check residual plot should show no funneling or pattern. In this example, data shows roughly constant spread. The test of normality or normality assumption: residual should follow a normal distribution. Check histograms, QQ plots, and PP plots or Shapiro-Wilk test of residuals appears approximately normal. Please subscribe and like our channel and press bell icon for more videos.